Hello, everyone. Welcome to our fifth podcast episode of Powering Up Your Formulations, sponsored by BASF Performance and Formulations Additives. My name is Luis Angeles, Global Additives Industry Marketing Manager in North America, and your podcast co host. For those who are listening to us for the first time, this is a podcast developed to provide more information about our additives portfolio that it is mainly used in the paints and coatings industry. We have a comprehensive range of respected brands and a broad technology based on different product lines. So we are distinguished for being a premier provider in these industries. On today's episode, my guests and I will have a dialogue about the 3D printing market, sometimes known as additive manufacturing or digital direct manufacturing. And I will say that this market is an innovative manufacturing technology that has gained notoriety in the last years. So we will learn today how BASF Additives portfolio is an enabler of these technologies. So let's introduce my guest. Hi Sayed, welcome to the show. I would like you to introduce yourself.
Thank you, Louis. Thank you for having me on your show. My name is Syed Hasan, and currently I'm the key account manager for security printing for the Additives and Resins Group. But I have spent 34 years at BASF in different positions, and one of my roles was a team member for the cross-divisional 3D printing team, focus team. And being part of that team, I learned a lot about the customers who were involved with 3D printing, also the materials that were being developed to make this possible, and the machine manufacturers, people, companies who are making 3D printers. So that is my background, and we'll take more questions later on. Thank you
Thank you,
again.
Sayed. Thank you, Sayed. I'm excited to having you. So, well, before to start, I would like to highlight some facts about the market because I recently learned that the 3D printing it is growing quickly. And in the next 7 years, it is expected a compound annual growth rate of 25% roughly. And I think this rise is driven by the digitalization and increase in the adoption of advanced technologies like this. And the other important thing to mention it is how much the North America region have captured in revenue share. So we're talking about more than 34%. And the other important point it is the technologies available in the market to support the 3D printing. So one of them is widely used, but I like that our expert explained about these technologies. So my first question to you, Sayed, it is
Mhm.
which technologies exist in the 3D printing?
So basically, there are many, but I'll focus more on three. So there are binder jet technologies, which actually use an inkjet printing head to jet binder. Then there's selective laser sintering. Then stereolithography, which is also known as SLA in short. And then third one is fused deposition modeling. So these are three main technologies, and there are various forms of that. For example, there is a variation of selective laser sintering that HP is using now. It's called multi-jet fusion. Very slight difference.
Okay, and based on these technologies, Sayed, so is there any differentiation among the three of them?
Yes. So for example, take selective laser sintering. This process involves a powder bed, and powder in this case is a polymer, which is mostly nylon 12 or polyamide in chemical language. Sometimes they also use a um, thermoplastic polyurethane. So there's a bed of polymer powder, which is then subjected to a laser beam that fuses the plastic particles, which are mostly 50 micron in size. And once those particles fuse, it basically forms a very thin layer of the cross section of a 3D printing part that you're trying to make. Then the powder bed is coated, rolled over with a new fresh layer of polymer, and then process is repeated hundreds and thousands times more until the final part is made. It is then removed from the build platform, cleaned with some chemicals, and then there are some other post-processing steps that are involved to develop full mechanical properties. Stereolithography, on the other hand, is contains a vat or a pot in which you have a photopolymer, which consists of functional oligomers, monomers, photoinitiators that we supply, as well as additives, which could be UV stabilizers or heat stabilizers. In this case, the UV light hits the liquid polymer and and solidifies a thin layer of that. And then the platform drops, a fresh layer of liquid comes on top, and then the process is repeated until you have the final part made. That part is then removed and cleaned with chemicals and put in a thermal oven for a post-processing step to develop the full properties of the part. The third one is fused deposition modeling, also in short called FDM. This uses two chemicals called ABS, which is acrylonitrile butadiene styrene, or polylactic acid, PLA. They take these polymers and form it and actually it has been converted into a filament. This filament is then extruded through a nozzle, which is heated. The polymer melts and it deposits a very thin layer of the part on a build platform. The platform drops and then another layer is put on top and the process is repeated until you have the finished part. So these are the variations in these three separate processes. Yeah.
After understanding this difference, Sayed, could you please explain or describe what are the pros and cons in the available 3D printing market?
Yes, so that's a good question. Selective laser sintering is known for speed and very strong mechanical properties, the final part that you make using that. So it is preferred, and HP has actually commercialized their multi-jet fusion technology, which is very, very fast. And you can make final parts, prototypes using that in hundreds and thousands of number. Stereolithography is a useful where you really need fine details and high resolution, but this is more expensive. That is the downside of it. In fused deposition, the low cost per part is very favorable to customers, and it is being used by hobbyists and consumers. So a lot of schools have bought small tabletop printers for less than $1,000, and they let kids in school learn about 3D printing. I've seen some parents who have bought 3D printers for their kids at home because they are so cheap and the materials are so cheap. But these FDM processes are not they don't give you much fine details, and the mechanical properties are not there. And for that reason, don't get fine details in that, but they are very affordable. So these are the pros and cons for these three different processes.
Excellent. And well, when you mentioned about the difference in the technologies, you started to talk about the key components in the formulations. And I think based on that, it could be important that you introduce what BASF additives can offer to the market.
So Louis, you know that in selective laser sintering, the polymer particles are subject to intense heat from laser beam, and that can end up in disintegrating the polymer. So in order to stabilize that, there is use for a lot of antioxidants and heat stabilizer like Arganox products, Argastep products. So they really help in stabilizing the polymer from degrading. So that's one. In stereolithography, you have to use photoinitiators that BASF has in its portfolio, Arga Q290, a cationic photoinitiator, and that is it has that photopolymer, no, not photoinitiator has very low toxic profile. So it is preferred and can be used. Besides, we have additives that can be used in fused deposition modeling because that is also heated, and we can use UV stabilizers there also, and heat stabilizers, Arganox. So all these additives which are used in a typical formulation, coatings and additives, the same thing applies here also, because in stereolithography, you have a full formulation that contains cross-linkers, monomers, oligomers, and they also need additives to take care of these few problems.
Understood. And let me do a quick recap about these products. So I think it is important to understand that the BASF Additives is offering these products that you can see in the slide, the tinubin, the UV light stabilizers, the Irganox, the Irgastab, and as you mentioned, the Irgacure 290. And I would like to ask you, how our additives portfolio offers superior performance through this product reference? And please link this with your description on the technologies available.
So I think the downside of any intense heat is in any situation when you are subjecting a product to high intense heat, it can lead to some destruction or degradation of the polymer, degradation of the polymer. So you have to use Arganox products with that. They can be added to the formulation so that when intense heat is applied, these products can actually protect the actual polymer from getting degraded. Same thing is true for UV formulations, where if you want to protect the final product from UV degradation, you will use UV stabilizers in that. Uh, in terms of photo curing, you definitely have to have a photoinitiator to start the polymerization process. Without that, it will not polymerize. And we do have Arga Q290, which actually is used in 3D printing applications to, especially in stereolithography. VMOX is actually a monomer that comes from our EM division, not from our division, but that has become a product that is much sought after by 3D printers, especially in the stereolithography um, market. There are various advantages to that. It is superior to other monomers. I think it is mainly because of its low toxicity profile, and we receive a lot of requests for samples of that monomer.
Okay. Thank you for explaining that. And I think, well, it is important that the audience knows that, well, we have this offering in our portfolio. But now, if we try to understand which application areas exist for the 3D printing, I also read that in different market studies that the aerospace companies started to explore this printing technology for manufacturing various hardware parts, and also the automotive industry has explored to show a huge adoption on the 3D printing. So having said that, which other markets or application areas can be explored through the 3D printing, Syed?
Louis, you're right. The early adopters were, of course, automotive and aerospace companies. For example, Ford and GE. They bought hundreds of printers, industry scale printers, to start making parts on their own factory floors. And these were parts that were made out of plastic, which are not critical. For example, fuel nozzles, manifolds, some under the hood applications, uh, because they could benefit from it by 3D printing. They could make hundreds and thousands of parts without having to spend weeks making a mold for it first, a prototype, and then they had to throw the mold away. So in short, I think that's why they were the early adopters because, as I mentioned, there are three advantages of 3D printing. Number one, extremely difficult and complicated geometries can be made using 3D printing, which cannot be made by traditional manufacturing. Number two, there's not much waste in 3D printing. Any excess powder or chemical that is left that can be reused or recycled. In a traditional manufacturing, you start with a block of metal or wood, and then you chip it or machine it, and there's a lot of waste. Now, there were some limitations about materials or the technology of 3D printers that could not be applied to make other things. But now that the materials are made and a lot of progress has been made, the next frontier I see as healthcare, dental applications, and it may not be a new frontier now because they've already started using it. For example, they are making the Invisalign braces on the spot in dental offices using a stereolithography. They can take a scan of the jaw and then exactly make an individualized brace for a person. Similarly, in war and accident, people lose limbs, legs, arms. Now they have the technology they can make the exact replica of those using 3D printing, and that is helping the humanity tremendously. Um, there are companies that are now making organic material that can be used for replacing parts in the human body. And these are materials that can actually grow and fuse with the human bone, and it can be used as a graft. So I think there are a lot of applications in the future that can benefit humankind. And as technology develops on all three sides, software, hardware, as well as material side, we will see tremendous progress in this field.
Understood. Okay, well, just to summarize, and please let me say, we Additives are ready to hand in hand with our customers, and I believe that our additives really powering up the 3D printing applications in the industry. So, Sayed, thank you very much for joining me today. I appreciate having this conversation with you. And let me also encourage all our listeners to reach out using our email contacts information or also writing us an email, but please also visit our website where you will find different solutions in our portfolio to support different industries. And well, having said that, I would just like to close and say thank you. Thank you to the audience for listening us. And well, Sayed, I hope you enjoy the show, and I will expect to having you again in the future. Thank you very much.
Thank you, Louis, and thank you for having me on the show. Thank you to the audience also for listening. Have a good day.